welcome to another episode of the Measurement Lab. I'm your host, Elijah Carey, and today we're going to be talking about the Actor Framework. And I'm joined by two of its creators and first users, Mr. Alan Smith, and its creator, Mr. Stephen Loftus-Mercer. Hello and welcome, guys. Thank you for joining us.
Hey, glad to be here. Thanks for having me.
So I want to get straight into the why, like what led to the creation of Actor Framework. But before we do that, I want to make sure the audience has a little bit of background on who you are and how you came to work in this domain. So Stephen, let's quickly start with you. What's your background and how did you get involved with Actor Framework?
I spent 22 years working at NI on LabVIEW as a software engineer on the LabVIEW team. And somewhere around 2009, I had a habit of every June, asking customers to send me, their stuff that they couldn't get working so I could tinker with it and see if we could make LabVIEW able to solve it better. And that June, I got essentially four almost identical projects from JPL, Exxon, a little company called Lapdog, and there was a fourth one, and I've dropped it now. They all had this massively parallel application, and they were spinning up huge numbers of simultaneous VIs, all trying to deliver data and throughput, coordinate messages, and they were all hitting the same four set of bugs. And, it just sort of all coincidental at the time. And so I started asking, can we just somehow rule these out or prevent them somehow? And I started building a verifier. I wasn't actually trying to build an architecture for writing their stuff. I wanted to build something where they could write a simulator for their application that was going to run slower than real time, that would at least give them, this is what it should be doing. And then we could, attach that to their main application and say, does it match the simulator? So the simulator would be easy to prove out, and then they could make their bigger systems match up against it. And I had some ideas on that. And then I discovered something weird, that if you're a US citizen and the project isn't top secret, you're allowed to go to the national labs and ask for a copy of their documents, like for whatever project they're working on. And within some reasonable limits, they will give you a copy. I'm like, really? And at the time, Alan was at Sandia, and I was like, "Hey,
no,
was it Sandia?
I just come from Sandia.
Okay." And so I was like, "For your next project, can I get a copy of your spec just so I can try doing this? Because I need a real project to try this with." And Alan's like, "Why don't we do it on the actual thing?" I was like, and he's like, "It's research. That's part of the national labs." Okay, so let's see if we can do this better. And we started working on it a bit, and a couple weeks went by, and Alan calls me up. He goes, "Okay, so it's working, but you should know that your simulator is running faster than my real application."
I think you're conflating me with another one of your developers.
Was that Exxon? Was that okay?
Yeah,
that was Kurt at Exxon.
Yeah, that makes a lot more sense.
It's running faster than the real application. I think I'm just going to use your simulator. And at that point, I went back to Alan, and I was like, "Okay, let's talk." And we started saying maybe this should be an actual real library. And
and so when you were coming to Alan at this time, Alan, who are you and what were you working on at this time? What's your background?
Okay, so I am Alan C. Smith. I've been writing LabVIEW code for over 30 years. I think 31, 32 years at this point. I go way back. I got my first LabVIEW was the demo version of 2.5.2. It came on like 8 floppy disks or something like that, way back in the little stack of floppy disks. I've been a consultant for over half my career, consultant or contract developer. It's always been LabVIEW. I did spend about 6 years working for a prime supplier for Sandia International Laboratories in Albuquerque. And then I came to NI for about 6 years as a system engineer. And now, last 7 years, I've been back out on my own as a partner again. From about, so kind of how I got into this. Steve and I always used to joke we needed to have two C-shirts. His said research, mine said development. Because I've been a developer. I mean, I've been thinking about this a lot lately, kind of origins of Actor Framework and explaining it to people. And we got, thanks to Stephen, we got queues, and then about 18 months later, everybody was using queued message handlers. That's my recollection of it. And When I went to Sandia, one of the issues with Qt message handlers is, of course, hey, I've got my string invariant combo, and there's great potential for typos and stuff to enter and give you runtime bugs. I went to Sandia. I worked on a very large project at Sandia where I was again doing a lot of Qt message handlers talking in parallel. Then I'd worked up some formalisms to take some of that. I sent the wrong message or the wrong data in with my message. Some stuff that had worked out on a prior project for Boeing with some other folks, and that was quite successful, and that worked. And then I wound up moving here to Austin, and was talking through some of that at a user group meeting, and came to Steven's attention because I was doing some of the things that he'd seen other people doing that weren't going well, and
he was right at the start of his project. That was important.
Yeah, you caught it in time. Well, I was arguing to do something that I won't. I was arguing for a DVR inside of a class as a way of having by reference classes.
That's a good way to get Steven interested.
Oh yeah, it is very much so. So we had a conversation, and he had me come down. He asked me to come down, and he wanted to show me something that he was working on, and he showed me some prototype of Actor Framework, and I remember looking at it and saying to him, "We're going to have a lot of message classes," and him going, "Yep," and that's okay. At that particular point, I was freelancing, and I had an opportunity to actually try it out on a live project. I always had the sense that it would scale. We'd approve it, right? So I had a chance to try it out on a small live project, and about my 23rd message that I wrote, I was like, oh God, we got to have some tools for this. So the back of my mind, I'm thinking I need to learn scripting so I can write some tools. But Steven and I went back and forth. He'd send me an updated version with something that he put in, and I'd go and apply that to my project. And so I one of the very first projects to use Actor Framework out in the wild. No tools, just like hand cloning off classes and stuff. And that actually is what led me to come to NI, because Stephen referred me to Tony Vento as a good LabVIEW programmer that he knew. And then I got to work on all the tools and stuff while I was there.
So let's make sure we put a fine point on the why. I mean, it's clear that Stephen, you came across a bunch of people with a common problem statement. Alan, you ran into it in the wild.
Mm-hmm.
What was the problem statement? How would you frame it as far as like why you felt the need that this thing existed? What was the gap?
The four bugs that everyone was hitting up against. You spin up a massively parallel application. So you've got lots of things all happening at once. You have something that's trying to coordinate them so that they all do things, and then you need their results to be coordinated back together to be presented. And things are coming and going, starting and stopping, all of this all over the place. And they were hitting the four bugs. Let's see. Deadlock, where one of the processes was process A waiting for process B waiting for A, and neither of them can proceed because they're both holding on some piece of data. The lifetime management, where they couldn't reliably stop a process, or they would stop a process before a dependent process, and they would start getting error messages through the system instead of a nice clean error shutdown. The echo chamber, where they would trigger a message on A, B would hear it, send a message to C would hear it, send a message to A, and A couldn't recognize that it was its own message coming back at it, so it would send it right back to B. And this happens a lot in UI type of applications where like you resize a screen and all the controls say, oh, that means I need to resize. And then they start bouncing. And there was a huge amount of effort going into stopping the echo chamber. And then the last was state stability, where A changes state. It sends a message to B and a message to C that says my state changed. And then B and C both, are okay, they're going to change. And then B sends a message to C that is predicated on C having already changed state, but maybe the message from A was a little slow, and suddenly C has a message that it has no idea what to do with because I'm not in that state. No one's told me about that. And so trying to keep that state consistency, lifetime management, deadlocking, and echo chamber, huge amounts of programming in lots of other programming languages was being spent on trying to solve these four bugs. And I said, well, maybe we can design a system where they just aren't possible.
Alan, is that which of those were those the four bugs that, or not bugs, challenges you were running into, or would you describe it differently?
So no, this was 14, 15 years ago, about midway through my career, and I was coming at it from the different angle. I have grown as a software engineer dramatically in the 14 years that I've been working with AF. But at the time, we'd been writing queued message handlers. I'd been dealing with things like am I sending the wrong message, or an incorrectly formed message. You write, well, cloning off a template of a queued message handler to make a new module. And then I've got to go back and touch every single one of my modules if I want to change that core template. A lot of really practical, more tactical considerations. Steven's been operating at a strategic level. I've just been operating at the tactical. I've got to write some code. I was attracted to the fact that AF was class-based. And so that would give us, hopefully more reuse potential. I mean, right at the gate, it's reuse because we're using the message handler all the time. I haven't written a message handler in 14 years, unless I have to come out of Actor Framework. So a lot of that we needed at the time. We needed a formalism because everybody had their. That's another thing that really appealed to me. Everybody had their queued message handling template. They're all a little bit different. It's like we need a formalism here. We need some standards that we can work off of. So that appealed to me. We do all the projects, off of the same baseline. Since that time, all of those reasons that I got into it, have really kind of grown for me, and that formalism that AF has imposed on what we do, I'm finding a lot of value in going project to project, and it's just a certain way that we do things when you're an Actor Framework and they're consistent.
I mean, both of the problems you described, I mean, is it fair to say that the common theme across all of them is I have a lot of different things that my system, a lot of different, for lack of a better word, actors in my system that are all doing different things and running at different rates, and I got to coordinate them. Is that overly simplified, or is that fair?
Massively parallel coordination.
And that's, that's every system I worked from about 1998 until today.
Do you think that challenge?
LabVIEW likes to be, people, everybody, you show them those two while loops running in parallel, and like,
yeah,
right, and so everybody does that, whether it's strictly necessary or not. It's even when it's not strictly necessary, it's incredibly powerful, and people like to use it. So when you talk about, Stephen talks about massively parallel systems that have to, with modules that have to talk to each other. Well, the little project I'm doing for a customer right now is not massively parallel, but it's parallel. We've got a bunch of things that we want running side by side. Well, so that's the other great thing, is that once you wrap your brain around the framework, right? You can write a small application in Actor Framework and be successful, and then go write a really big application in Actor Framework, and it's all the same stuff,
same tools,
same thought process.
The fact that it's so common that our customers have, to your point, it's like once you have that second while loop and then a third and fourth, it feels like it's a natural way to express a system that interacts with the physical world. Is that something that you think LabVIEW just drives by nature of the graphical representation of these loops, or is it something that's really driven by the unique nature of the requirements of test software and all the physical things it needs to interact with?
Neither. I would say it's driven by the data flow nature of LabVIEW, not its graphical nature per se. Yep. I can easily make two things run at the same time, and the compiler will figure out how to actually put the instructions together.
But is that any less necessary in other languages?
No, it's just harder.
Yeah.
Okay.
Yeah, it's a harder thing to do elsewhere. I am told by people in the know that it's still 2 pages of C code to get 2 parallel loops. And I've always just been able to do that in LabVIEW.
It is much easier in the modern C++. You can spin it up in just a couple of lines of code with your start thread and join thread, but your memory management of what is in each thread and everything, good luck.
It's still pretty exciting. Yeah, I've only ever been a LabVIEW developer, and partly because it does line up with the way I think, and a part of it is, there's a while loop for my data, there's a while loop for the UI. Very first parallel application I ever wrote was split the UI off from the data acquisition.
So It sounds like the original idea that led to Actor Framework goes back maybe 15 years or so, depending on when you start the clock. And how long after was it when you first deployed Actor Framework into a production system? I guess presumably at Sandia.
I think it was
No, this was after Sandia.
It was after Sandia. I think it was 2011.
I was doing stuff in 2010 with early prototypes.
Yeah, I guess I didn't think you'd actually delivered working code until early 2011.
Might have been. It was right around there, end of 2010, early 2011, somewhere in there.
That was when when I was out of research and he was doing it, and when he had started doing it enough that we knew we had to get some scripting tools around it.
That happened, and that's like I came to NI, and I think within 2 months I was reaching out to Darren about how do I write scripting tools, because really, honestly, about my 23rd message, I'm like, we're not going anywhere if we don't have tools around this.
Yep.
And to be clear, I was also an early user for demos of a Actor Framework that predated the message maker.
Yeah.
So I remember those times as well.
Yeah.
So, now, I guess 11 years ago, you had the first version. It wasn't then that we actually shipped it in LabVIEW itself, right? There were still a few years.
This is the first version.
2012. Okay.
Yeah.
So I know since then there have been, like, I personally interact with a lot of our users, and I've seen how it has been widely adopted across a lot of industries and application areas. I'm curious, based on your exposure and interactions with our customers, some of the more exciting or challenging use cases that you saw Actor Framework be used to address.
I mean, the most interesting for me, was the, Phoenix Nuclear Labs, where Casey was driving, massive systems to generate the radioactive particles necessary for MRI machines. And watching that application push the boundary of, computation and just throughput, and having it stand up and keep going I was like, that was really incredible.
Yeah, Phoenix is. I actually wound up doing a bunch of work for Phoenix. Both while I was at NI, I helped with some of their initial, Casey Lamers came to my desk that Casey Lamers wanted to use Actor Framework on Rio, and my boss was like, "Well, it's not proven out, so we tend not to recommend people do that." I'm like, "It's just C code; it should work just fine." And sure enough, it does. Or not, sorry, G code, I should say. Excuse me. Yeah, and should work just fine, and it does. Works great. But I was off and on a consultant for Casey my whole time in system engineering. And then a couple of years after I left, I wound up going and working on one of their projects. They have a, cargo container sized neutron gun. That's their flagship product. And then they plugged that into a number of other things. They make medical radioisotopes with those neutrons. They do material scanning for the Army. I went to them to work a project that involved one of their neutron guns plus the materials handling for nuclear fuel rods, because they would, how do you test your nuclear fuel rod to make sure it works? Well, you shine a bunch of neutrons on it. It's like shining a flashlight on a glow in the dark toy, right? So you shine your neutrons on it. It gets all excited and happy and starts throwing neutrons back out, and you measure. You measure the number of neutrons coming off, and it tells you the quality of your fuel rod. So we built this whole big Casey's company built this whole, working with several subcontractors, built this whole apparatus for moving these, and they're like 1 meter to 4 meters long, these rods, to move these rods, walk them past the front of the neutron detector, park them somewhere for 40 seconds while they do the analysis on the emissions, and then decide if the rod is good or needs to go for some further inspection. And so the neutron gun itself on the Rios is all Actor Framework, and then the supervisory software for running the system. They wouldn't let me onto the PLC. They wanted all the actual to be on the PLC. It was kind of a drag, but there you go. But all the supervisor work and moving the rods around, it's all an Actor Framework project.
I I will say, in I think there's a natural progression that we see in LabVIEW applications where you get to this threshold of complexity and size where you need something like this. And of course, actor frameworks now one of a couple of different options that are out there. But whether it's actor framework or an alternative like DQMH, like when you get to a certain scale of things you have to talk with, like you need something like this. So I can't help but feel like it's a natural evolution for a lot of our customers once they get to that level of scale. So it just so happens that, the larger you get, typically the cooler the application area is. So it tends to overlap. But
That. Yeah, and you don't write X controls for an actor framework system because we have actors.
Yeah.
We don't.
Well, and the MGI toolchain is actually one of many, right? Since you guys brought actor framework into this world, there's been quite a number of tools that have been made available for actor framework with quite an impressive number of downloads. What are some of your other favorites besides the MGI toolchain?
Would it be self-serving of me to mention network endpoints since I wrote them?
Yes.
I think the litmus test is if you find them a critical part of your daily workflow, then no, I don't think it's.
Alan, I will mention network endpoints because I started developing on them. I couldn't quite get them to work right. Alan needed something, and then I was like, oh, well, yes, that'll work. Thanks, Alan.
And that was based on having done the same kinds of things on pre-actor framework actor systems. The one I did at Sandia, I had a lot of those communication connections I had to make between Rio and host. Actually, that was between field points and host. Actually, it was way back then. And I wrote that when I was at NI, and I wrote it on spec. I wrote it because someone's going to need this. And it originally was linked network actors, which I wasn't happy with. We actually made a change to the actor framework. That's where the receive message override came from. Steve had a different idea on how to go about it, which also works quite well. But that paved the way to make the network endpoint version that we have. That was actually why I got hired at Phoenix, because we had to talk to a whole bunch of things that weren't necessarily actors or weren't necessarily NI systems, right? We had third-party applications we had to talk to. We actually used a version of that. We used network endpoints and changed how we serialized the messages so we could talk to these other things. So I keep an eye. I curate the actor framework list on vipm.io. I was harassing Jim Crean about getting some stuff on the list, and he just said, "Alan, just do it because you know what should go on that list." So I curate that list. And I kind of kept an eye on the number of downloads that the various packages have, because I'm curious. And monitored actor, which has a replacement now, is number one. Last I checked, it was about 16, maybe it's probably up to 17,000 downloads at this point. I want to get people away from that for some technical reasons, but monitored actor fits an important need. So it was the most popular. Part of what drove it is that it is a required package for the panel actors. And although I'm planning with MJ's permission, I'm actually planning to release a version of that doesn't require monitored actor.
I was going to say, if you want them to stop using it, what should they use instead?
Well, I've got this. I'm working with a couple of customers. I'm not quite ready to post it, but I have a version of the panel actors that does not call monitored actor, or doesn't inherit from monitored actors. So it's
and there's something to do with the dependency chain that you're trying to.
Yeah.
Change,
So
right?
Ask me that question in a second because I want to finish this thought. But monitored actors are number one, about 16, 17,000 downloads. Panel management, that whole package, which is actors and then all of the supporting classes if you want to do your own thing. It's second. Last I checked, it's like 15,000. And then you have a big step down and you get to network endpoints. The third most successfully downloaded package in Actor Framework, it's about 2,000. People clearly need to make UIs when they don't always have to talk across
the others are specialized tools that, you don't have the same level of, they're not the generic solve the common problem of every application.
Right.
You get a lot of specialization. There's some hardware specializations that completely wrap a particular device and make it just show up as an actor in your system and stuff like that.
Mm-hmm. And there's tools that aren't they make debugging and support easier, and those get less downloads as well because I think they reason I'm not entirely clear on, but I think it's that people know I need panel actors to download this. Everybody needs a UI. Not everybody realizes that you need to bounce in the browser. So,
well, I think, Alan, just not everybody writes bugs in their code, so they don't need all those debugging.
I started unit testing. I don't write bugs in my code either.
What's funny to me is like when we first started talking about Actor Framework, and I think one of the first times I know I was involved with it was an NI Week keynote where Simon Hogg and I wrote a demo using Actor Framework that was like a wireless CDAC chassis, and we created a Angry Eagles demo.
Angry Eagles.
I remember that.
Yeah. At the time, it was largely viewed as an extremely advanced technology reserved for an elite few. And it's amazing to me how, to my earlier point, now when I go to meet customers, it has been so broadly adopted, again, along with other analogous frameworks for managing large numbers of independent free running things that you have to talk to. And I think part of it is just how our customers' complexity and their needs have really exacerbated the need for some solution in this space. So it's clearly been a very popular tool, and it's not surprising to see it's just impressive to see the number of downloads and the number of tools that exist.
It's not just how complex it's gotten. That's always been one of the illusions. As soon as you have two pieces of hardware, you have this problem. And
yeah, that's fair.
So even a very simple system of, look, I've got two independent wheels that I need to tell them both to stop. You need the coordination ability and stuff. It's amazing how quickly you hit this and how unacknowledged as a real problem it is for beginners. Like this is almost a thing we do. A lot of training materials will all stop with, okay, we showed you how to do one piece of hardware. Go, now you can code the world. And you miss that the scale up that happens at that second one is a non-trivial scale.
Well, you remember, Stephen, the prompt for the very first internal LabVIEW user group that you and I set up that was probably like 16, 17 years ago.
Yeah.
The very first, which that user group still meets every Friday inside the walls of an eye. But the very first prompt was what, Stephen?
How do you stop two while loops?
How do you stop two while loops?
And I bring that up in the Actor Framework course as an example of how soon you hit this problem. I've been pushing back on the Actor Framework is complex. I think that the most cringeworthy thing I've ever heard is that you have to be a CLA to use Actor Framework.
Yeah,
and it's
particularly now with the interfaces.
Yeah,
we got rid of the hard part.
Mm-hmm. Yeah, interfaces make it so much better.
Kids today don't know how good they have it. Back in our day, we had to write the messages by hand.
That's my first 20 or 30 messages
barefoot in the snow.
Yep, both ways. No, I have had the experience of taking. I unfortunately, this was why I was at NI, but working with some of the application engineers and training them and stuff, and taking them through here's OO and here's Actor Framework, and these are they work with LabVIEW 2 years or less. Are they system designers? No. But that takes a long time and a lot of experience, and I don't care what platform you're using. Are they capable of writing actors that solve problems to a specification that their technical leads provide them? Yes. That's one of the great things I actually think it's why part of what drove us going to these parallel modules in the first place is that you could give the CLD exam used to be, basically go fill out a queued message handler to solve this one problem, right? We got to the queued message handler, and suddenly here was a thing that existed all by itself that you could give somebody and say, I want to send these commands, and I want it to give this data out, and I want it to control these things, and that's a very discrete package that you can give to a junior engineer. And we get that in spades with Actor Framework. Once you get people past the I don't see it all in a block diagram, once you get people past that, then which Bowser helps with a lot, by the way.
Yeah,
I have to confess, I taught a LabVIEW class at UT recently, and of course, at the end of the hour and a half workshop, a student was like, "Hey, how do I stop two loops?" And I was like, "Oh," and I felt so terrible. I was like, "Okay, I'm going to use a local variable, but don't ever do this." Like, because I only had a few sides. Like, there's a quick and dirty way, but this is not how you should ever do it. So that in that element of like, I only have a few seconds to give you an answer that works. It's still, simplicity versus
this guy right here has told me, and it's in the Actor Framework course, is that in certain situations, if you control for all of the bad things you can do with a local variable, it's a very lightweight way.
It's hard to beat the number of clicks required.
Yeah. Yep. Well, hard to beat the number of clicks. And if you properly constrain it and you don't, the problem with all of these things, local variables, global variables, and so on, is not, for the use cases they're designed, they're perfect. It's all of the potential for abuse.
Right.
It's the scale. It's the lack of scalability. Hey, let me, I have a few more questions for you guys. I want to, so when I think about Actor Framework, we talk a lot about like communicating and managing entities on a system, but these days it's very common to be talking about containerization for the sake of scaling compute across multiple execution targets and scaling up and scaling out. So, for people that are thinking about containerization and this level of scale of compute, how does Actor Framework exist and adapt to those types of compute requirements and scalability requirements in this modern era?
Quite well. The more CPUs that you have, the more parallelization you've got, and the more you want to take advantage of it. It's not how well does it scale, it is the scaling.
But what if the CPUs aren't on the same machine?
Okay,
that's why we have network actors for.
Yeah, and that was the Phoenix application of the 6 computing platforms that I had to talk to. Only one of them was, well, 2 of them, because we got to count the neutron gun. Only 2 of them were LabVIEW. Network endpoints let you change how the message is serialized, and you can change it to be JSON. And once you do that, you could have a TCP/IP connection sharing JSON code around wherever it needs to go. I've also built actors as backends on web services, right? You have to go from a command response regime to a message-based announcement regime, so there's a bit of a shim layer there, but it's fine. So and as Steven says, it's kind of like when LabVIEW went from Windows to FPGA, and the while loops were truly running independently because that's what the hardware did. I've got 2 actors that run independently, and if I put one on this computer and one on this other computer, great. Now they just happen to be running on 2 different cores. That's perfect.
So can I effectively think of an actor as almost like a containerized piece of code in the same way people refer to containers in kind of the broader sense?
It's not quite as broad as, it's not an independent running OS level process, but you can certainly build them at that level if you start breaking your LabVIEW application up into chunks and you're communicating over your pipes or GPRC and stuff like that. I've never actually seen anyone do a remote procedure call with an actor from one actor to the other, but it could be set up. It would require just a specialized endpoint that knows how to channel those messages across the network.
Sounds like a fun weekend project. Or really, is that not an obvious intersection of channel wires?
Oh yeah, if we got the channel wires advanced to the point where it's driving some of that.
Okay, so maybe I'm getting ahead of myself.
That actually, if you start going down that road, you start asking the question, well, why is it that I can't visualize all my actors in one diagram? Why don't I have a diagram that visualizes the actor connections? And then, you start talking about actors as first-class citizens and all the, there's a bright future out there of things you can do to really make it so that we can express a whole system in LabVIEW that, we've ooched towards over the years, but never quite figured out the way to really get that true visualization out there. But wouldn't it be cool?
Yes.
Wouldn't it?
It would be lovely to be able to here's my system diagram of my actors and how I want them talking to each other. And there it is.
Yep.
I love it.
And then I drill down one of the actors, and I open up something like Browse the Browser, and I can flip through the initial block diagrams of the actors, and you can see all the pieces.
Alan, earlier you said you wanted to come back to a question I asked. I believe I put you on the spot about the new design that you're.
Yeah.
I don't want to. I want to make sure we cover that.
So, we developers are passionate folks, right? No slight to Jarek Trepanier, who saw a need and filled it well with monitored actors. He saw a real problem that honestly was a blind spot for me, because for whatever reason, actors work great in my brain, and I never really particularly needed monitored actor, but it is hugely popular, especially for people who come to a new system. The problem with monitored actor is that everything in your system has to inherit from monitored actor. And there are a few things about monitored actor I'm not excited about. That's neither here nor there. But if you want to take your debugging code out of your system, you have to change the inheritance of everything in your system. That is a code change that breaks validation, that dirty dot stuff, that's more commits in source code control. There's a lot of, for this nice bit of software architecture, there's a lot of software engineering ick that goes along with it. Again, no fault to Derek. He didn't have access to the core of AF. I did, and there are, as a part of the debugging package that's in there, I realized one day, it's like, all the hooks I need to give the functionality of monitored actor are already built into actors. Make a couple of little changes, and then we can have a tool. It's the Actor Hierarchy Inspector. It's available on vipm.io. I haven't checked its download recently. It's probably under 1,000 still. And so we can get all the same functionality and not have to have monitored actor. But that left us with panel actors inheriting from monitored actor. I had seen enough of them. Steven was raving about them, and I had a couple of customers now that really, actually I had one experience with another customer who was already using them. I saw just how drop dead sexy that was, but again, I don't want to use monitored actor. So all you have to do is make your panel actor non-inherit from monitored actor. I reached out to MGI and I said, hey, I want to put this out as a package. We can call it the unmonitored panel actors. Can I do this? I didn't want to step on any of their stuff. It's not my IP. MGI said, sure, go ahead. I've been using it successfully now with a couple of customers. It's on my to-do list to make that repo available and post the package for it. It is because like one or two little features in monitored actor that don't really affect much of anything in panel actor that aren't there anymore.
You should say that it's already released, and that way when he releases this video, you've got a deadline to get it done.
Yeah, in fact, we'll put.
I have too many deadlines. Right, I need. Okay, I will try to do this before the end of the year as a Christmas present to the community. I have a couple of things that I absolutely have to get done first. But I will make an effort to get that done because people need it.
And some of that work that you're actively doing is actually very relevant to this topic, which is, as many people watching hopefully know, we are open sourcing Actor Framework. Now, what does that mean? Well, Actor Framework ironically started as an open source project that we brought into the product, and the source is something you can freely explore and navigate. What's important in our work right now is that we're actually posting the source on our GitHub organization such that the community can collaborate and we can pull those contributions back into future releases of LabVIEW. And so Alan, and Steven, knowing that, Alan's been instrumental in making this happen, what are the things you're excited about when you think about the future of Actor Framework, especially knowing now that it's open source?
I have a way So right off the bat, we solved a very real problem with Actor Framework in terms of building PPLs. You can get a clean build of the Actor Framework library as a PPL with everything you need to have access to. That's done. That's in the repo now. There's a main branch, which is just the shipping Actor Framework. And there's a develop branch that has this new version that is just a reorganization. So you can build a BPL. We didn't realize how important that was 10 years ago, how important that was going to become 10 years ago. So there was a nasty little dependency we had to sort out, which is now done. So I've been wanting to push on that for a couple of years now. There was no avenue to do that because everybody I knew at R&D had left. And there wasn't anybody whose direct responsibility was for AF. It's like we needed a path forward to be able to put things into the product somehow. We have multiple tool writers writing great tools. It's been painful to compare to the development arc of DQMH, which has continued with new tools and new stuff that are being adopted as official, and knowing we didn't have a way to do that with Actor Framework, which was going to have the effect of forcing people into DQMH who didn't want to go that route. And it's important to have choices. So the thing that I'm excited for now is that we do have a way to be working our own open source projects or our own private projects and offer them up to the community for incorporation. And we were all doing our own independent thing, but if you needed to change in the core library to get some important tool, there was no way to do that.
Yeah.
Now we have it.
And I'm really excited too. I mean, there's a shockingly active and large guild of folks that are really focused on Actor Framework. Some of our largest customers have standardized on Actor Framework as their framework for their application. So I think this is a huge development, and I'm excited to see the contributions of the community, especially knowing the number of toolkits and add-ons that have already been created in its current form. So Stephen, Alan, any other key points about Actor Framework or the future of Actor Framework you wanna cover before we wrap things up?
No, it's doing what I designed it to do, and I've been pleased to see its growth.
Well, and you should be very proud of the impact it's had, both of you.
It's pretty awesome to look around and see everything we've touched with our little framework.
Awesome. Well, if anyone watching this has questions or comments for Stephen and Alan, feel free to leave a question in the comments section below. Or if you have a way in which you used Actor Framework that you think is especially cool, we'd love to hear more about it. So please do join the conversation in the comments section. As always, like and subscribe for more Measurement Lab videos. And Stephen and Alan, thank you so much for your time and for all the work you've done and for sharing your insights on this really cool technology.
Yeah, you're welcome.
You're welcome.
Happy to be here.
Take care.